Hello, this is David Compatore, Technology Development Scientist at Lumetrics, and we're going to talk about intraocular lenses, measuring them with the OptiGauge II. There are two key parameters we can measure with the OptiGauge, the haptic thickness and the center thickness. The haptic, some of you might not be familiar with that, is the little things that stick out from the edge of the lens. There's two of them, and they're used to center the intraocular lens on the pupil. The surgeon implants it, very carefully centers it on the pupil, and then these haptics make sure it stays there. So you want to get that haptic thickness correct, so that you have the right spring tension, so that it's good and centered in the eye. The other thing you're going to measure is center thickness. That's another critical parameter of an intraocular lens. Intraocular lens's power changes with the curvatures, and steeper curvatures cause a stronger, a fatter center thickness. So higher power lenses are a little thicker than lower power lenses. The lens we have right now is a 6 diopter lens, so it's actually fairly thin. Let's try to get the haptic thickness first. I'm just doing it by hand here and by eye. And I'd say we got it. So this is the the top surface of the haptic, and this is the back surface of the haptic. And this is probably the case. We don't care about that, but that is nice in that you can see we're measuring the intraocular lens in the case. So the probe above the intraocular lens in the case makes it very easy. Just keep the lens in the case and measure it right in the case. So let's see, we've got a haptic thickness of about 0.5 millimeter. We are estimating the group refractive index at 1.5, which is good enough for just a quick demo here. We could, of course, use our RICs to get that very accurately and make this material thickness very accurate. But for this demo, we'll just work with the 1.5. So there we go. We got a haptic thickness of about 0.5 millimeter, and I know from experience that's pretty common. So we would say that was good. And now I'm going to try to move us just by eyeballing it, the measurement dot into the center of the IOL, so that we can get the intraocular lens CT. And I'd say we've got it there pretty well. We got about 383 microns for the center thickness of this 6 diopter lens, which is thin, but that's correct for a 6 diopter lens. So I would say we've got a good lens here, ready for implanting. And that was all done with the IOL in the case. Simple, easy, and fast. All right, this is David Compatore. Hope you enjoyed this video, and see you in the next one.